My name is Will Gibbons, and today I'll be taking you through the webinar. Thank you for attending today's webinar about animations. We're going to cover a lot of cool stuff today. Now, before we actually start, if you've attended a KeyShot webinar before, you may know this, but we often get these questions, so I want to address them up front. This presentation is being recorded, and it will be made available afterward on YouTube shortly when it's available. The slideshow that we're going to be using for the presentation will also be made available to download in PDF form. The KeyShot package file, which will be used as a demo today, that will also be made available. And since we get asked about the computer quite often, we're using a 3 gigahertz 8-core 2013 Mac Pro, and it's got 16 gigabytes of RAM. And during this webinar, if you have any questions, feel free to type those into the chat box in the GoToWebinar panel. We have other Luxion employees on the line who will gladly answer those questions as they pop up. The other thing I want to mention is that KeyShot animation is a pro feature. So anyone here using KeyShot HD, they may not have access to these animation features, but any of you pro users will have access to KeyShot animation tools. Now, in today's webinar, we're going to cover a number of things. We're going to start off with looking at the advantages to creating animations and why you might want to use KeyShot as an animation tool. And then we'll look at some strong examples and some specific examples that we will then talk about how to recreate in our hands-on portion. When we look at KeyShot animation principles, we're going to be covering some of the best practices as well as just some of the overarching traits of KeyShot's animation tools that once you understand makes KeyShot's animation tool a lot easier to use. We will take a closer look then at individual part animations and what all the parameters inside those dialog boxes are, and then we will get hands-on for a demo. And during that, I will walk through how to create part animations and then how to make modifications to those, how to link those animations, and just some overarching workflow and organization that, again, also as your animations get more complex, will help you manage those as well as create those consistently. And we will wrap up in usual fashion with a Q&A at the end, so you'll be able to, again, ask your questions, and if we have time, we will address the ones that are most relevant to today's topic. And so without further ado, I'd like to jump into our presentation. So KeyShot has the ability to create animations in addition to just still renderings. And that begs the question, then what's the real advantage, or why might somebody want to animate in KeyShot? Well, you have the ability to make the great looking images that you already do in still images, but if you can bring a sense of motion to that, you can bring your products to life. And this is a way to create a more powerful presentation. Usually we're creating images to share with somebody, whether it's to pitch an idea or show off a product or a concept. And we want that audience to be engaged when we are showing them our work. So ideally, a more engaged audience is going to respond to your work better. And if we can create animations that are more engaging, then that works out for both the audience and you as a content creator. Additionally, we can appeal to those people by creating moods, which happens to work a little bit better in animations where you have moving parts. Perhaps you even want to get fancy and add some music to it. That's, another thing you can do, but bringing a sense of motion to your objects and using that to create a mood, whether it's fast or slow or elegant or jarring, that's all something you can do just by using simple animation tools to then make your presentation a little bit more interesting. And and some of the other benefits are that you can show things such as the function of a product. How does it work, or what does it accomplish? Maybe it's a tool or something. Or maybe the assembly of a product if you're doing instructions or documentation on how something goes together or comes apart or can be serviced. Or maybe there's multiple joints in something and you want to show how those are articulated, or the relationships between certain parts or assemblies or sub-assemblies and how those cooperate with one another. These are all things you can animate and communicate much more effectively through an animation than sometimes just still images accompanied by text. Now, before we actually start talking about how to use the animation tools within KeyShot, I want to share a few examples that show a bunch of different ways to kind of accomplish the same thing, which is, again, making a more engaging presentation or just showing more than just a still image of a product. In this first one, we have a nice exploded view of this product, and it explodes along a few local axes, and we'll explain what that means later, but that's a great way to show, again, how various sub-assemblies go together and come apart, as well as show the whole of this product in a nice little short clip. In this next example, this is a payment processing product, and you'll see here where the user creates some other products that basically it shows the relationship between this product and the products that you use to make your payments. So whether it's a credit card here or a smartphone or a tablet device with a technology to make payments on it, you can see here how they're using another material, which is the tune material in this case, on the product to kind of differentiate and show how that function works. And all the while having the main product animated and kind of rotated slowly here and there, that also shows off the materials it's made of, as well as the surfaces, whether they're flat or curved. So it does a good job describing the product. And in this next example, we have a watch, which is a nice piece of jewelry, but it does more than just having a second hand and an hour hand that moves around. This mechanical watch has quite a few moving parts, and one of the highlights of this watch is really, or the main feature, is this movement, which is shown off during this animation here as well. So there's lots of small animations happening here within this product, which show it's a lot more impressive than just a standard off-the-shelf simple watch. And in this example, we have a fairly common-looking plastic product, a housing of some sort that holds a few other parts, but it's got an articulated hinge and a collar that gets pulled off. We also see the parts move apart from one another, and we get to see how to disassemble and reassemble a portion of this. And so something like this does just a fantastic job showing, again, how somebody might interact with this product, and there's a number of ways this could be useful, whether it's internally within a company or somebody who's going to be using this product, or maybe just to market this product externally as well. Again, these are all simple product animations focused primarily on the moving parts within these assemblies, and that's what we're going to be showing today. In this very simple example here, we have a little alarm clock, but it's brought to life and maybe, tells a bit of a story here too with the ticking hand, which is really nice. And that attention to detail with how that second hand moves around and kind of bounces as it ticks into each position is another little bit of detail we can talk about later as well. But it's all built on a very simple principle, which we'll be getting into today. And here's an example of a product that I created for this webinar. And this is kind of showcasing all of the animation types that we'll talk about, at least the part animations here. So if this was a still image, you may not get the full understanding that this is a drone with propellers that actually allow it to fly, and that those legs fold up into itself, and it's got this camera that it uses to navigate, and it can fly around. So again, there's just a lot more of story that can be told as well through an animation. And not to play the whole thing over again, I have just a little short clip, but I wanted to show the same, or a portion of that same animation in a tune material, because we'll talk again about the advantages that rendering in tune has, in some cases, over realistic materials. And it has a totally different feel to it, but it'll render a lot faster, which is nice too. So just to plant some seeds there and show some nice examples of what can be accomplished and achieved using KeyShot's simple animation tools. That's really what we're going to be talking about today. So where do we even get into the animation workspace within KeyShot? Well, it's actually right in front of our eyes at the bottom of the KeyShot user interface. So there's a button that says animation, and all you have to do is click on that, and it launches a docked workspace at the bottom of your KeyShot window right underneath the real-time view. And in this case, you are going to have access to a few things. We have our timeline, which is going to show where the playhead is within our animation. We're also going to have our animation properties. Those are going to be on the far right-hand side. So when we have an animation or an individual transform selected, we will have access to making adjustments to those individual parts of the animation on the right-hand side. We also have a toolbar which contains all of the more or less controls that you have access to within the animation workspace. And we'll break that down and look at what those are a little bit after this. We also have on the left-hand side a list of animations, which is not too different than you're used to with the list of our materials in our library, but they're going to be represented on the left-hand side there. Now, the animation principles are, again, as I mentioned, the items that are really going to be kind of generic or general, kind of all-encompassing properties or practices that you're going to want to be mindful of as you create these animations. The first of which is animation types. So KeyShot has the ability to create 3 distinct types of animations at this point in time. Part animations are where you have your geometry being animated or moved around. Camera animations are those that you apply to our camera, and in KeyShot, our camera is essentially what we are viewing our scene through at any given time. And then we have a material animation. So if we wanted to really animate or fade between maybe a couple different materials on a product, that's what that is. In our case today, and for this webinar, since we don't have time to cover all of animation in depth, we're just going to be focusing on the first one, which is our part animations. And again, there is a lot that you can do with simple part animations. The next principle that I want to touch on is KeyShot animations are built from individual transforms. So these transforms are kind of like the building blocks of our animation. And I've got a very basic diagram below that kind of illustrates this. So those colored boxes, in this case, would represent individual transforms, and the entirety of those are or that's what makes up our animation. Those individual transforms can be either moved around, replaced, kind of shuffled around, or dragged throughout the timeline. They can be linked to one another, so you can have multiple parts being animated driven by one transform. We can also scale these linearly by dragging where they start and end, and we can mirror these if we want to create an animation and then undo it. So think of maybe an exploded view that then reassembles itself. That's a big time saver. We can also do things like group these together in folders, and that helps us organize and categorize our various transforms as we begin to build a more advanced animation. And all of this we will be showing in the live demo portion. I just want to kind of show that this is how you work in KeyShot's animation, as opposed to, say, keyframing and some of the other tools that you may be used to in other animation practices. So the third principle has to do with pivots. And KeyShot offers the ability to select a pivot at any given time, and that pivot is going to help you move another part in relation to another piece of geometry. So in this case, any piece of geometry can be a pivot, and those pivots serve as the center of the rotation. And by default, when you select a part, the pivot is going to be set to the center of that part's bounding box. But again, if and when you need to, you can select on a piece of geometry outside of that part or subassembly to be the pivot. And at some point too, you can, if needed, use dynamic pivots, which is something that happens or is used when you don't have an assembly that is built with perfectly ordered subgroups and in good assembly structure, which we will talk about as well. In the example to the right here, we see an animated linkage where we have 4 subgroups and 4 levels to that animation. So each subgroup is going to be animated one at a time, and based on the assembly structure, it creates that sequential animation of the entire link or linkage that we want. So the 4th principle is assembly structure, and I started to talk about this prior. Assembly structure is going to be something that anyone who uses CAD or 3D applications that support assembly structures, they are going to be familiar with what these are. And this is just a way for your geometry to be organized in such a manner that it helps manage all the different parts. So in KeyShot, when we apply an animation to an assembly or a subassembly, everything that assembly or subassembly contains is also affected by that animation. This prevents us from having to make many animations to every single part within our assembly. So it simplifies the process. And in the diagram to the right, we can see, again, kind of a stylized, simplified version of this. If we have a model that has 2 assemblies in it, and that first assembly contains 3 subassemblies, that first subassembly contains 3 parts, and that first part contains 2 faces. So this is just kind of me showing a breakdown of what an assembly could look like. And those blue boxes that encompass those, that represents each level of animation. So as you animate at different levels, you're going to move not just the part that you're animating, but anything else that is enclosed by a parent assembly, basically. And the 5th principle that we're going to touch on is, or I should say, are axes. And axes have to do with the center coordinates, or the coordinates of a given part. So they can be either local or global. And in KeyShot, our global axis is going to be kind of in the center of our KeyShot world. We'll have an X, a Y, and a Z axis. In the center of those, where they all intersect, is our origin. And as anyone who works in CAD applications, they're going to have local axes for each part that is inserted within an assembly. An assembly is going to have a local axis, its subassembly will have a local axis, and so on and so forth down the chain. And this is another thing that offers KeyShot users who use CAD applications a lot more freedom and flexibility when it comes to creating animations. For those of you who are using Surface modelers, maybe Rhino or something like that, I hate to say it, but you are a bit out of luck here, because it does not actually use the same assembly structure when building those 3D parts. And when you bring those into KeyShot, you don't have quite as much information to work with as, say, some of the CAD users do. So an example of what this looks like, sorry for the siren, we have a global axis translation that is applied here to all of these screws. And if I wanted to move all these screws out from the center of this object, and I chose global axis as my axis that I'm going to translate them along, I would be out of luck. Only that top screw is moving the direction I want it to. Everything else outside of 12 o'clock there is going the wrong way. Well, this is easily fixed by using what's called a local axis, again, as demonstrated by the image we had a couple slides ago. So if I play this animation, we'll see all of a sudden the same linked animation is applied to every one of these screws or bolts, but they are moving along their local y-axis. And since each of them, the local axis moves with that piece of geometry, these all go in the same direction that I want them to. And if this still isn't clear yet, it will become clear when we do the hands-on portion. So those are axes. And those are the 5 principles I wanted to touch on. Now, part animation types, these are the actual options we have within KeyShot when we choose to animate a part. And these are the ones that we are going to be using to build our overall animations today. So part animations include 4 simple animations. That is a turntable, translation, rotation, and fade. And you see these when you click the animation wizard. It launches the animation wizard, which is a dialog box that gives you options to choose either a model or part animation or a camera animation. The first option that we have is our turntable, and this is simply going to rotate our model around KeyShot's Y up axis, or KeyShot's up axis, which happens to be Y in this case. So when you select your model, which is in most cases going to be the assembly, it is going to rotate the whole thing, and it will use just that one axis, and you have 2 options. You can rotate it around the center of the model or the environment. And then you have the option to either go counterclockwise or clockwise, and that's it. You can choose the number of degrees it spins, and because all of our part animations utilize the same time settings, we will talk about those after we get through all these. And then just to demonstrate, a turntable would look like this. So that chair is made of multiple parts, or the assembly of that chair is multiple parts, but the entire model itself spins around its own center in this case. Now a translation is our next option, and this moves a part in a linear direction, so a single direction. And in this case, we are going to have the ability to choose X, Y, or Z, and how far it goes in that direction. Something I want to mention here is that those values, or the numbers that you put into those translate boxes, those are going to be in the scene units that your KeyShot is using. Because in the example I will use, it was modeled in millimeters, that's my scene unit, and if I want to see the effects of one of these translations, I need to make sure that that number or that value is high enough or large enough that I can see the effect. So I know if you're not thinking about that, you might just use the default number, and 1 millimeter, depending on where your camera is and how large your object is, you might not really see that move. You need to try a larger value, or if you had modeled something in, say, meters, it may be a very large number, and it may then all of a sudden disappear from your viewport, so you need to maybe dial that number back. So keep in mind that those are unit aware. And finally, we still have the option to choose the axis orientation, whether it's original local, which is going to be the local axis of that part, or it's going to be global, which is going to be KeyShot's world axes. So an example of a translation is going to look like this. It moves in one straight line, and then it moves back because I mirrored that as well. Now a rotation is just as it sounds like. It's rotating a model around an axis. It can be either global or local, and we have the option to include pivots now at this point using this type of animation. So we type in the total number of degrees we want it to rotate. We can select our axis, X, Y, or Z, and whether we want that to be local or global. But then we also have the option to choose a pivot point, and we will talk a little bit about those later. But again, a pivot point is kind of a helper piece of geometry that can allow you to rotate around another axis or in another orientation that your model may not allow you to if you did not have the advantage of building in or working with a true assembly structure that has good subgroups and local axes for that matter. So here's an example of a rotation in 2 axes. It's going in one direction and then the other. And our last example here is a fade. So we can then animate the opacity of a model or part using a fade. So if we want to fade our scene from like pure white to, having all of a sudden our part being shown or our model being shown, we would start with an opacity of 0 and then fade to 100%. Now I want to throw in there that you want to make sure that you fade your model out before fading it in, because you can run into some funky issues there. But again, we can talk about how you can make sure that you fade your animation out prior to starting the actual the rest of the animation. And this is an example of what that looks like. So the entire product fades from 100% to 0 and then 0% to 100 again. And finally, our time settings. So I didn't want to go through this for each slide, but the time settings are underneath every one of our product animations, and they are the same for all of them. In this case, they're going to allow us to control the actual timing or the speed of this animation. And we get the option to ease our motion, which is going to control how the part moves, whether it's at a constant rate or if the velocity is going to change over time. And then we can also choose a starting and ending point, or just define a duration for that entire animation as well. And so these are what we will use quite regularly to control the speed at which our animation is played out as well. So just to visualize this, on the left we have an example of linear motion. So you can see that the rocking chair looks really unnatural because it's rocking at the same speed, which does not happen in real life. So if we ease in and ease out from all of the translations applied to this rocking chair, we see that it looks a lot more natural and a lot more believable. We also have the option, this is not in our translation dialog boxes, but it's going to be in our right above our timeline, and we'll show you this too, but motion blur is something tied to time a little bit as well. So the left we have the same thing where we have no motion blur applied, and on the right we have motion blur applied to this object. So you can see it's ghosting a little bit as it moves back and forth, which is something that happens when an object is moving a little bit faster than the shutter of your camera. So we'll get into that, and that's a great way you can convey motion or speed, or whether it's the spinning wheel of a car or maybe the propeller of an airplane or something like that. And that's a quick sneak peek into the various animation types that we have for part animations. And the next part here, we are going to get into our actual demo, get hands-on. All right. So I have a demo scene here that I have just opened up earlier. I've done nothing with it. Everything is set to the default. I'm going to unpause it, make sure my windows here make sense. I need to change the size of my real-time view. And in this case, I'm going to go ahead and make sure that I'm using an aspect ratio of 16 by 9, a little bit wider. And this is something you might want to do in the very beginning before creating an animation, because in this case, if you want your animation to play back on most devices today in full screen, this is going to be your safest bet. So one thing I'll throw out there is just 16 by 9 aspect ratio is a great place to start. The next thing is that once I've done that, I can go ahead and, if I care to, I can unlock the resolution and I can adjust the size of this a little bit. So I want to make sure all my windows are here, and as I scale this down, this will retain our 16 by 9 aspect ratio while giving me all the space I need to work. Next, I'm going to click on the animation button down here. So we are launching our animation workspace as previously mentioned, and this is where we're going to be creating our animation. Now, this is an undocked workspace, and then we can redock it by dragging it down toward the bottom. And for me personally, I think it works well at the bottom of your KeyShot window here. So I'm going to drag this up so I have a little more space to work in there. And I want to next take a quick look here at the toolbar here that I had mentioned previously. So right here on the left-hand side, we have our animation wizard, and then we have our frames per second. This is going to allow us to change how many frames we have for every second within our timeline. And depending on what you're doing with the video or the animation, where it's going to be played, if it's going to be edited in another program after the fact, those are largely what's going to define how many frames per second you wish to render out. However, I will mention that the higher the number of frames per second, usually the smoother the motion is when it's played back. In our case, we'll just stick with 30 for today. Here we have our standard buttons. This will bring our current time indicator back to the beginning or the end of our animation. Since we haven't added anything, those won't do anything at this point. We also have a rewind and a forward button, as well as a play button. This little guy here will loop our animation and play it over and over, which can be helpful if your animation is still fairly short and you want to see what it looks like looping. We also have the button to the right, which allows us to add motion blur to our cameras or our model or part animations. Right now, I'm going to make sure it's disabled, so it is enabled when it is blue and it's disabled when it's gray. So we will play with that later. And then lastly, on the far right, we have our preview. And if I click on this, it will start rendering out a preview of our animation. It will not show me that now because we don't have any animations yet. But I also want to mention the gear to the left. That's where we can play with a couple settings for our preview render as well. And now that we've taken a look at that, we are going to check out our assembly structure of our model on the right-hand side. So this is a SOLIDWORKS assembly built in SOLIDWORKS and then directly imported into KeyShot just by importing the SOLIDWORKS assembly. I'm going to also change my perspective here to something a little bit larger, maybe 65, just to flatten it out a little bit. The perspective was fairly extreme there. So now when we look at our assembly, I've got everything named and labeled. We have our master assembly at the top, and it's a drone. And then we have a bunch of sub-assemblies. So there's the base of the drone. We've got a legs assembly. Then we have the arms, which have propellers attached. And then we also have our camera assembly. And then we have the head of the drone as well. And all of these are made up of various sub-assemblies. Some of them are a lot more layered than others, but that's our basic setup. Now let's say the first thing we want to do, I'm going to apply just a couple materials on here so we don't have a plain naked piece of geometry. And I'm thinking we're just going to be working with a stealth drone today. Keep this simple. So we'll be mostly black. The first thing that we're going to do to animate this is work on these propellers because I want to get some motion in here. So I will launch the animation wizard by clicking on the button down there on the left, and it launches our animation wizard dialog box. And in this case, I want to create a rotation because I want those propellers to spin. So there's a couple things we can do. We can browse in our assembly until I find it, which can take a little longer, or I can just click in the real-time view and select that part directly. And in this case, I'm going to hit next, and we have a few options. So we can choose the rotation, and I want to, at this point, rotate it, we'll say 360 degrees just to start. And then we have the axes. We can choose X, Y, or Z. If it starts in the wrong axis, we can always click on a different one to change it. In this case, if I scrub forward a little bit, I see it starts going in the wrong direction. So I fix that by choosing Y-axis. So I know at this point it's at least on the right axis, but it's not staying where I want. It's kind of moving around its own center, its own global axis. So I'm going to click Original Local, and I also want it to rotate around its origin as well. And then at this point, I should be able to go ahead and choose Ease In because I want it to start a little bit slower and then speed up over time to add some realism. And as far as duration, this is how long it's going to last. So I want to make it about 10 seconds to start. Those will be spinning throughout the entire animation. And at this point, I'll hit finish. And if I go ahead and test that with the play button, you can see it slowly picks up momentum. And at that point, it's of course way too slow. So I can click on my animation on the left to select it. And we see that the properties become visible on the right-hand side. So if I scroll down, we see we're only spinning 360 degrees over the period of 10 seconds, which is just too slow. So let's say I wanted to spin maybe 3 times per second. That would be 1080. And I also need to multiply that for every second I have. So times 10 seconds. And I hit enter. That's going to give us the correct speed that we're looking for. And it should speed up and look good. Excellent. So the next thing that I want to do is apply that to these other propellers. Now, of course, what I can do is copy and paste that to each propeller, and that's going to prevent us from running through that animation wizard and creating the same thing over and over and over. If I were to go to my scene tree, you'll see that we now have added a little animation icon, which is the circle with the arrow on it, and it's listed right underneath the part it's applied to at this point. I can actually copy this by right-clicking on it in the scene tree, and I can actually right-click and then paste it onto another scene tree item to speed up the process and just avoid going through the animation wizard. But we can also do one thing better than that. If we were to do that, we end up with a bunch of identical animations on our timeline. What I will do is go ahead and select the other propellers in our scene tree that I want to animate. And I'm going to multi-select them by holding Control or Command. And then right-click and go to Animation and paste a linked animation. And this does not actually create any more additional animations in your timeline, but it does indeed animate those pieces of geometry altogether. So if we go ahead and play that back, we should see that they all slowly start up and they are working together. Fantastic. That's exactly what we want. So the next thing that we can do is say, well, we want this drone to lift off the ground once those propellers get up to speed, right? And in this case, that may be in the 4 to 5 second range. So what we're going to do is launch the animation wizard, go ahead and choose translation, because a translation, remember, is a linear movement. We're going to translate the entire assembly of the drone from the ground up into the air. So we'll hit next, and in this case, we want to translate it in the Y direction because we know it's going to go up. That's both the drone's local up direction as well as KeyShot's up direction. And remember, I'm in millimeters, so I want this to be a fairly large number. I'll type in 300 to start. And what we can go ahead and do now is, again, drag our time indicator up and see that it does indeed lift off the ground. And it's about where I want it to. So there's no need to really make any changes to this other than just maybe make it last a little bit longer than 1 second. Of course, we can use the arrows or we can type in a value that we see fit. So in my case, maybe 1.5 seconds would be ideal. And again, remember, our motion easing is going to control kind of how natural this looks. And we want our drone to kind of ease both in and out to accelerate in speed toward the center of that, the middle of that translation, and then slow back down. And I can also make sure that starts at a later time. So I'm going to start it at the 4 second mark and hit finish. So now if we go ahead and play that back, our drone's props speed up and then we lift off the ground. Pretty good. All right, so the next thing that we want to do is get into those legs, because those legs articulate and they have a couple of points where we want to rotate them around. And there's some cool stuff that we can take advantage of because we have, again, an assembly structure. And also, if we look at the right-hand side on our scene tree, we are seeing our propellers rotations underneath each part. I can go ahead and close those now. And we also see a different icon that shows us that we've applied a translation to the entire assembly. So it affects everything underneath there. That's pretty cool. So the next thing that we want to do is take care of those legs. So when I look closely here at this assembly, I want to first fold in the bottom portion of the leg. And we can go ahead and launch our animation wizard again, but there's another thing we can do is we can access from the scene tree and create an animation that way. So if I go ahead and click on the first leg subassembly, I want to isolate the bottom portion of it. So if I open it up, I see that at the very bottom there's an assembly that contains both the pin I want to rotate around and the leg itself. If I right click on this subassembly and I go to animation and I choose rotation, we've now applied a rotation to it, and we can change the settings in the settings area on the right hand side instead of running through the animation wizard, which saves us a couple steps, a few clicks, saves us some time. And so I'm going to go ahead and see first what this looks like. You can also notice that it's been placed, that animation's placed wherever my current time indicator is at. So if I go ahead and move my that current time indicator, we can see the drone is still moving up at that point. So I think I'll move the animation of the leg over, the rotation, and we see we're getting toward the end here. We don't see the rest of our animation. Two things: we can either scroll with our scroll bar on the bottom, or we can zoom out with our magnifying glass to see more of the animation timeline. So here we're seeing a rotation that's less than ideal. It is rotating in the wrong way, and so what we're going to do is go ahead and try the original local axis, and this is because, again, I know that this was built with the center of this subassembly was actually at the XYZ origin within SolidWorks. So we're going to be taking advantage of that local axis to do this rotation. If I click on the origin here, under the pivot point section, we don't actually need to pick a pivot point because it's set to self. So it's looking at this subassembly. And I know that the origin is indeed the axis we want to rotate around. So I click on that, and we see our part goes back where we want it to. This is a good sign. That means we're on the right, we're in the right direction. Now we need to change the direction of our rotation. So I'll apply a negative sign in front of our 90, and I hit enter, and it updates. So now we know we're folding in, which is exactly what we want. And now we just need to find the value that we need to put in here to get the leg folded up inside itself. And I happen to know that that's actually 140. Again, just to save time, we're not going to trial and error it here. But if I go ahead and drag my time indicator here, we can see that that leg folds up perfectly into itself just the way we want it to with that rotation. So just like you might expect with the other one that we created with the propellers, we're going to copy and paste this as a linked animation in order to prevent some redundancy in our workflow. So in my scene tree with that animation, if I right click it and I copy it and I go ahead and expand the other leg subassemblies, I'm going to find where I would like to apply that animation. So I've selected those, the bottom portion of those legs, and with a right click I can go to animation and I can paste a linked animation. And what we see is all those legs disappear, or they seem to. That's exactly what we want, because we now see they're all folded into themselves. So we're going to repeat the process one more time at the higher up one level or one group level in order to fold the next segment of those legs up in the opposite direction. Okay? So what we're going to do is, just like we did before, I'm going to go ahead and find the first portion of the first leg's assembly. That's what I want, and I'm going to right click on it, go to animation, add a rotation, and in this case, if I move my current time indicator forward, we see it's going the wrong way again. I'm going to repeat the same process because I built this model again correctly in CAD with the origin in the right location. So now all we're doing is we're folding up too far. So I need to change the degrees of rotation. I'll try 50. It's not quite enough maybe. Do 55. And I think that's looking pretty good. We can tell because they're parallel, and that was my design intent. That's what we want. So at this point we're good, although I would like to do one other thing, and that's go ahead and ease in and ease out. And we may need to adjust that on the previous one as well. I will check in a minute. But now that we've created this, let's go ahead and make sure we select the right one in our timeline. I'm going to copy that animation, and I'm going to go ahead and apply it to the remaining leg subassemblies, paste linked, and they follow the first one, which is awesome. I'm going to do a quick save just to make sure we don't crash here and lose everything. I'm going to throw this on the desktop. And right here, as we play this, we indeed have our drone legs folding up. Let's make sure we don't have linear motion on our first leg translation. And if we wanted to, we can go ahead and see what this looks like. I'm going to zoom back out. We can go ahead and play this. Pretty good. And now one thing too that you might notice, depending on the materials you're using and everything, and the machine you're on, this may be struggling, KeyShot may be struggling to render those while playing them back at the same time. If that's the case, we've got a couple things you can do. One, you can go ahead and put it in performance mode, which may help. The other thing you can do is go to your window, show your geometry view, and the geometry view is kind of a simplified OpenGL type viewport, which, let's see if I can scale this down a little bit. This should allow us to play it back without having to do any real-time rendering. And this is a nice way to check the overall motion without it having to, again, perhaps slow down because it's rendering. So depending on how you like to work, I just wanted to mention that's another option there. If you're on a laptop too, that would be a really valuable option. The other thing here is the legs we have folding up sequentially, but that's probably not as interesting or realistic as them going a little bit together. So we can click and drag these transforms so they start to occur either one right after the other, or maybe we just want them simultaneously. We can work freely like that within KeyShot and then just update the animation as necessary, which is the beauty of the animation tools. And this is really, although just the beginning of the animation, the example animation I created, this is these are all the steps that I used to create it. So even though it got complex in that there were many little transformations or animations happening, it's just a rinse and repeat process. And one thing that you might want to do is, for instance, when this drone takes off, let's say we want to land that drone at some point. One thing we can take advantage of is mirroring. So if I right-click on this animation or this translation, I can right-click and I can select mirror. And what that does is it mirrors it, so I have now the same liftoff, but it's in reverse. So what I want to do is put this at the end of my animation. So if I zoom out, I go ahead and place this toward the end of my animation. Also, I want to think about, the legs are not back open again. So I would want to go ahead and open the legs as well. So one way we could do that is do our mirror again. But before that, something I might recommend is some organization here. For instance, we have nothing here is actually named. So the first thing that I want to talk about in the bit about workflow and organization is that you can name each of these transforms. So this first one called 01 prop A rotation 1 is not terribly descriptive. So I can go ahead with that selected and type in the properties prop rotation. And now we see it is updated on the left in the list. And then the next thing that we have going on is takeoff. So I might call this takeoff up, so we know it moves up. And if we really want to get descriptive, I can type in 300, so I know it's moving up 300 millimeters as well. And then, of course, I would do the opposite for the mirror and just call this drone, or I'm sorry, mirror take off down 300. And something else we could do here with the legs opening and closing, we can go ahead and actually multi-select those holding shift. We can add those to a folder with a right click. We can call this folder legs fold, and now they've been added to a folder. And what's cool is we can go ahead and uniformly scale that animation. So as I drag that folder's length out, I can either speed it up or slow it down, which is really nice. And of course, I can mirror that entire folder. So in this case, if we want the animation, the drone to move up, the legs to fold up, and then the legs to unfold, and then the drone to sit back down, we should be looking pretty good here. I'm going to go ahead and move these two folders up so they're right next to one another, and go ahead and play that back, see what it looks like. And there we are. Pretty good. And we see it starts over because we had that loop on as well. One other thing I'd like to mention, I know we're really getting to the end of our webinar here, so I think I'll wrap it up and we can have a few questions answered here. But I do want to show that with the motion blur, what difference it makes. So if I enable it by clicking it, it becomes blue. And if we pause the time indicator, if we drag it out partway, we see this cool ghosting effect, and that is the motion blur. And this is a great way to do, say, a rendering, take a still, or even an animation, and convey speed, and that is having your motion blur enabled. Now, it will be a little bit more intensive to render out in the real time, but I do think it adds quite a bit of realism, and you can get an idea of what things are going to look like. And the faster your object is moving, the more motion blur it's going to have when you pause that animation. And again, the demo went a little longer than anticipated, but hopefully that was thorough and helpful for you guys. And I think at this point, I will check in with the other Luxion employees that are on the line to see if they have any questions that we would like to discuss or that I could answer. But for those of you who need to get going or have a place to be, thank you for tuning in, and hopefully you learned a lot about product animations. Hopefully you have some cool ideas and you've been inspired to bring some life into your renderings. And if you do, we'd love to see those posted on our forum as well. Let us know how it goes. Thank you very much. Do we have any? Oh, hey.
Excellent presentation. We have some attendees that are really looking forward to the next webinars on camera and material animations already.
All right. Good to know.
So yeah, it looks like we do have quite a few Rhino users actually, and
okay.
So they're wondering if they're not able to create an origin in Rhino, how do they define a rotation point that is not the center of the part?
Got it. Okay, that's a great question. So for those who are using Rhino and are unable to take advantage of local axes that, say, a CAD user might be able to, we do have some workarounds in KeyShot. They may not be quite as elegant, but one thing we can always do, there's two options. So first and foremost, if you want to go ahead and use a piece of geometry that your model already contains, to use that as a pivot, we can go ahead and do that. And it will essentially look at the center of that piece of geometry. For example, I'm going to disable all of my animations by unchecking the boxes here, so I can just show you a quick example of what this might look like. In this case, this is a somewhat nonsensical example, but it will still work. So if I select this propeller and I go ahead and create an animation and I want to rotate it, we can choose to rotate it around a pivot point And in my case, in my example, I went ahead and let the pivot point be the center of the origin, but we can also choose a different pivot point by selecting pick. And again, from either the real-time view or our scene tree here, we can choose another piece of geometry. And it may be tough to see, but what it's doing is it's showing an axis in the center, this little red line, of this other piece of geometry. And indeed, it will rotate around that center once I hit OK. So if I make this value 360 degrees and I scrub through this and I back out of here, we're going to see this actually move around that piece of geometry. And that's what we call, that's picking a pivot point, but you can use either existing geometry, or if you want to go edit, add geometry, and use one of our primitives, that's a what we call helper geometry. So the example of the rocking chair that I animated back and forth, that was done using a piece of helper geometry that was hidden from view to translate back and forth as well as rotate around that pivot. Does that answer the question?
Yeah, it does. Perhaps you can just show it quickly one more time on one of the legs and use one of the little metal pins as the pivot.
Yes, we can. So in this case, we let's say we want to take the outer leg, the bottom portion here. Trying to make a little bit more space. So if we wanted to animate this piece here and rotate it again, I can go ahead and say that we want to choose a pivot, because right now if I scrub through, we'll see it's not moving in any direction that is desirable. I can select pick, and again, because it's in my viewport, I will just select it. And the center of that piece of geometry, because this is built symmetrically, is going to be exactly what I need. And in this case, it's the x-axis I want. So as I scrub through here, we can see that it is now rotating along that piece of geometry's axis. And of course, if I want that to go the other direction, just a negative value. Is that what you had in mind?
Cool. Yeah, and then just to reinforce the other option, perhaps you can add a cylinder and move it into place to show what you would do if there wasn't existing geometry there.
Understood. And actually, if it helps you to think of it as a cylinder, that is absolutely fine, but I find it sometimes helpful to see it on another piece of geometry like a cube, because the actual shape does not matter. Now I'm going to grab my cube and I'm going to scale the cube up. And what actually is going to, in this case, what's going to work here is the fact that the cube is the same width as it is long, and that's going to help us go ahead and it will find the center of that cube, which is going to make it a useful piece of geometry to pivot around. So if I go ahead and just move this into the right location, and it's going to be close, maybe not absolutely perfect, but we can take this leg here. We can go ahead and apply an animation and select this piece of geometry, that cube. And if we move through that, we're going to see that, again, it's moving the way we want it to, and it's, oops, not quite yet. There we go. Basically, what you're going to end up finding is that some of these options down here, because there are a lot of different variables, and it's dependent on both the geometry you're using, a lot of these options toward the bottom here, whether it's in the pivot point section, these are going to help you more or less troubleshoot kind of what you're going to have to use in order to create the desired animation effect. And then, of course, with that piece of geometry, we would want to hide the cube. And it is out of view.
Also handy to hide and lock the cube in case you're hiding and showing the top level, so that way it just always stays hidden.
Absolutely, great point.
Cool, well that's it for questions from my end.
I know we had Josh and Richard on the line, so if they have anything, they can chime in. Otherwise, if there's anyone hanging around, we can also answer those.
We have David Edson asking, is there a background to render animations that you can overlay over additional video? Not sure I'm totally following that question, but I think that's a good opportunity to mention a new feature that's coming in KeyShot 7, and that's a video map, which will allow you to embed textures as animations inside of your KeyShot scene.
Yeah, it sounds like that another way you could address that too, if it's more of a compositing issue. When we go to render out animations, you can render out frames with transparency, and what you would then do in another program is load that frame sequence over whatever plate that you've shot as your background, and then render those out in the video editing program. But as you mentioned, in 7, we'll be able to do that essentially too. So,
somebody else is asking if you can add sound or text in KeyShot.
So not at this point, not directly in the way you might think. So sound is no. There is there have been some clever workarounds with titles and stuff. So in the animation example you saw where there's text on screen, that is not something that you will do in KeyShot. However, there are examples of where people have used a label that has words or letters on it with transparency applied to a plane, and that plane is then positioned. So there are workarounds, but not as an option where you can just add text in KeyShot.
Okay. We have some questions about material animations, and we'll have to cover those in another webinar. Somebody else was asking if you can create a quick exploded view, maybe just separate those sub-assemblies in a linear fashion.
Yeah, we should be able to. I'm trying to think of which one lends itself best to it. But one thing that we can do is go ahead and if I multi-select a few parts, actually I don't want to do that. I want to go ahead and grab my animation wizard. I'll use this, and I can do a translation. Select the first part I want to move. Let's go ahead and make this in the Y direction with a value of, say, 70. Then we'll go ahead and say linear. We'll ease in and out. Take maybe 2 seconds or so. In this case, we can go ahead and see that that moves directly off. And what we'll want to do then is in the scene tree, find that animation. So what I always like to do is click on the part so I can quickly find it in the scene tree. I find the animation, copy that, and I want to make sure I apply it to the next couple of pieces. And then with a right click in the animation, paste linked. So those are going to move up, and I can go ahead and say 70 is not enough, maybe 150. And then this part we could then follow with a secondary animation. Now, I would not use that same exact animation because it will move exactly with those 3 other pieces. So what I could do is just do another animation to this. Go ahead and select it here. And then if I see that that's, go ahead and open this about 120. So that's going to move up at the same time. Or, well, that's the thing. We can move it so it moves at the same time, or we can have it delay a little bit. So first off, those 3 plates move up together, then the next piece comes up, and then maybe I want those 3 parts underneath it to move together. So I can go ahead and do one more, translate this piece in the same direction, maybe just 100 millimeters, and then copy that animation and make sure I apply it to the following parts. I can multi-select those just like usual. Right-click those in the scene tree, paste linked animation, and those should follow the other 2 pieces. Deselect those. So if we go ahead and play that, and you can just go ahead and keep tweaking this to your heart's content, and then if you wanted to then put those in a folder, we can always right-click, put those into a folder, call it explode, and then of course with that folder we can always do a mirror when we're done, and I believe that mirror is now showing up down below. So let's go ahead and put these 2 next to each other so we have them happening sequentially. Yep, and then when we play this back, there we go.
Awesome. I think we have time maybe for one last little demo, and that's with the fade animation.
Absolutely.
Yeah, someone is asking, can you start with all of the objects hidden and then fade them into view?
We can. The way we're going to do that, we're going to create a fade animation where we fade out and then we fade in after that. So that will give us the effect of starting with nothing shown and then everything is showing. So we can do that by, I'm going to start off by doing my animation wizard. We'll choose fade. We're going to make sure that we select the entire assembly, and we're going to fade from 100% to 0%. And in this case, I want it to happen very quickly because it's just going to be the first second of my animation. I'll hit finish. And after that, we're going to fade the whole thing back in. We can also, of course, let's see if we can just do a mirror. Should be able to. So we can fade that back in. Now, of course, you're asking then, well, I don't want to see it fade out in the first place, and that's absolutely fine. What we can do there is we should be able to change our starting point. So if we grab this, the crosshairs, as we drag this to the right, these crosshairs are going to identify, or the cross-hatching is going to identify the areas of our animation that is not going to be played. We can actually watch it here, but when we render it out, we can render out the work area instead of the entire animation. And that's just going to be the area that is not hatched out here. So if we go ahead and start it from this point, it's already hidden